السلام عليكم ورحمة الله وبركاته. Welcome back يا شباب. إن شاء الله نحن we talked about the kinetic theory of matter, okay, and we talked about what heat is, what internal energy is, and then some simple experiments. Not only this, we even talked about the polling experiment and the polling experiment and the smoke cell experiment, and I said the explanation is kind of the same. But that's the first part. So you have to understand, by the time we are done with this now, I expect you to understand that heat is just movement of particles, whether it is a molecule. And in this chapter you have to use, when you are talking about pollen and smoke, you have to say what? You have to say particles. You have to use the word particles. When you are talking about a liquid or a gas, you have to say molecules. You have to use the word molecules. So you have to learn when to use the word particles. This is for smoke and pollen. You have to know when to use the word molecules. This is for water and what? Water and liquids, other liquids, alcohol and stuff like that. And a gas too, and gases. Most of the gases are molecular. But when you are talking of helium, which they like, helium is atomic. Helium is atomic. Ya jamaa, you need to know the sciences are just close to each other. So for helium, so helium is an atomic gas. So when you talk about it, you use the word atoms. The atoms of helium. You don't say the molecules of helium. Helium doesn't exist in molecular form. They like helium because they use it in balloons. And you will see that a balloon is rising, it's filled with helium. Explain what happens to the helium. You say the helium atoms. That's how you talk about it. And then the last one is when you're talking about metals. Metals are made of electrons and positive ions, or you can say atoms. So you have to be careful when you're using these words, when to use particles, when to use molecules, when to use electrons. So please be careful about this in this chapter. Very, very important. Yeah, don't think that you are in physics, nobody now will ask you about this. Actually, if you mess up anything, مثلا in an explanation like this, explain why the pollen are seen to be moving very fast in random direction. Then you say, oh, the pollen molecules, طوالي, you get it wrong. You just mess up the marks. So be careful about that. Now let's go to the second part, which is gas pressure. Gas pressure. Now you will be wondering, why do we study gas pressure? Now, from your knowledge of general physics, you will know that pressure is force over area. You must understand this. Pressure equals to force over area. The reason why a solid applies a pressure, the particles of solid are like this, is because there is a force. These molecules, the particles of solid are in direct contact with the surface. They are in direct contact with the surface. That's why they are applying a pressure. Okay, because there's a direct force on the surface. Same thing to a liquid. But gases are different. A gas doesn't actually touch the container. They only collide with the container, but they don't constantly touch it. So when you blow into a balloon, how is it able to apply a pressure on the wall of the container, even though the molecules of the gas are not touching it? So you have to understand the problem. Solid pressure is straightforward, liquid pressure is straightforward because the molecules are in direct contact. They are applying a constant force on the surface. But for a gas, that's not the case. The particles of a gas are not actually touching the container constantly. So how are they able to apply a pressure? So when you're explaining gas pressure, it's mostly a 4 marks question. We explain it in terms of momentum. In terms of momentum. And for those who don't know, momentum is a value when you multiply mass and velocity. If you multiply mass and speed, that's what you call momentum. Momentum is mass and velocity. And you might also be wondering, what does momentum have to do with this? You have to explain it in terms of momentum. So, and this is how we'll do it. We're saying, assume you have a balloon, okay, or a container, and that container, say this is the balloon, This is the balloon here, and this balloon طبعا has some molecules inside it. Let's say it is filled with oxygen. Okay, I said if it is filled with helium, we will say these are atoms. Now, how are these things able to apply pressure here? How are they able to apply pressure inside the balloon? So number one, you say the molecules, I'm using molecules because I'm assuming it's oxygen. The molecules collide with the walls of the balloon or any container they are enclosed in, and they bounce back. Very, very important. They're colliding and they're bouncing back. Very important. So that's the first thing that happens. So as these molecules move, they just collide with the walls of this container like this, and then they bounce back. They collide and then they bounce back. These ones collide and then they bounce back, like that. So they collide with the walls of the container and they do what? They bounce back. That's the key word. That's the first marking point. Type. So when they bounce, keep in mind that their velocity changes. Okay? Their velocity changes. Why? Because we said when you bounce, your direction changes. So if this was plus v, let's say you are moving as plus 3 meters per second, let's say plus 3 meters per second. If you come back, even if it's with the same speed, your velocity will not be the same. Velocity has direction, so it has to be minus, meaning it's in the opposite direction. And plus and minus will never be the same, so we say the velocity changes. Now, if the velocity changes, the momentum is also changing. mv, this is momentum, this is the first velocity, and then mu and mv, sorry. mu, mv. Now, why am I using u and v? U and v stand for the velocity, and u means the initial velocity and the final velocity, and these two velocities are different. So basically, since the velocity is changing, their momentum is also changing. Their momentum is also changing. So we are saying you have to write that their momentum therefore changes. Their momentum therefore changes. Type, how is this important? You have to understand also now that a change in momentum is what people refer to as a force. A change in momentum is what people refer to as a force. How is that? How does that even make sense? This is how it makes sense. Force equals to ma. Everybody knows this. Force is mass times acceleration. It means a force is basically mass. Now, you also know that acceleration is v minus u over t. If you've watched the videos, v minus u over t. This is just a proof. It's not important. It's just to make you understand better. So basically, this is mv minus mu over t. Let me write the u and the v. mv, if we open the brackets, mu over t. So it's from this formula here. And if you know that acceleration is v minus u over t, then that's good. That's good. So v minus u over t is what we call acceleration. So you can clearly see this, that if you have a change in momentum, like momentum 1, momentum 2, and then you subtract them, that is what we call f. Waste the time. We are saying logically, your momentum will not change within no time. It will take time. If your velocity is changing, you take time to change from one speed to another. So time here is automatic. So we are just saying, if you can prove that the momentum is changing, then you have proved that there is a force in physics. If you can prove to me that there is a change in momentum, that there was an initial momentum and a final momentum, then it means there is a force. And time will always be there because it takes time for something to change. It cannot happen within no time. So that's why we are saying their momentum changes. Therefore, they exert an impulsive force. Impulsive force. Type, what's an impulsive force? They exert a force for a very, very short time. A very short time. Like when that small period where they're hitting, they exert a small force. So you always have to mention it like this. So what are we explaining? We want to explain pressure. For you to explain pressure, you have to explain where the force is coming from, and that's what we've done. So their momentum changes. The molecules collide with the walls of the balloon, and they bounce back. Their momentum therefore changes, and they exert an impulsive force. Type next. You say you've explained where the force comes from, but that's only for one molecule. So you're saying now the pressure exerted is the sum of all these forces. Remember, you're only explaining one molecule, so add all the forces exerted by the molecules that are colliding divided by the internal area of the balloon. That's how the pressure comes about. So you're saying the pressure now becomes the sum of all the forces divided by internal area, and these are the marking points of this: 1, 2, 3, and then 4. It's always mostly a 4 marks question, as simple as that. That's how a gas exerts using pressure. So we are saying, if you don't understand how momentum and force are related, here you go. If you can prove to me that a change in momentum is force, then you're good. Inshallah, that's all about gas pressure in terms of explanation. Gas pressure type. There's something you have to explain sometimes. What do you think will happen if the temperature increases? What will happen to pressure? What happens to the pressure? Let's say I've increased the temperature of this balloon. What will happen to the pressure? So as you will predict, you expect the pressure to increase. Type. The pressure increases. The pressure increases. Why? The pressure increases. And the pressure increases because we are saying the molecules will gain more kinetic energy. Like these molecules will start moving even faster. So when they collide with the wall of the container, they collide faster with a greater speed. So they will have a greater change in momentum. So they will exert a greater impulsive force. And then you say the pressure now increases because you have a greater force. As simple as that. So you have to use the aspect of comparison. You have to compare. You start your explanation off by saying they gain kinetic energy, they collide faster, okay? They gain kinetic energy, they collide faster, they have a greater change in momentum, and then they exert a greater impulsive force. A greater impulsive force. So, this is at a constant temperature. I forgot to. This is a constant volume. Like the volume is the same. So you have to keep this in mind. You have to learn how to explain it if the temperature increases at a constant volume. What will happen to the pressure? What will happen to the pressure? The pressure increases. Type. How would you explain that? Why is the pressure increasing? It's because the force is increasing. How is the force increasing? Because the particles gain kinetic energy first, and then they collide faster, or more frequently. You can say they collide faster or with a greater speed, or they collide more frequently, and then they experience a greater change in momentum. Type. So that's all we said about what? That's all we say about gas pressure. When it comes to an increase in temperature. Type. Sometimes you will be also expected to understand, okay, assume this is a surface, let's say your finger or the wall or anything, and this is a syringe. And this is a syringe here. And a syringe has something that moves inside it. Okay? So this is my syringe, and this is the plunger that moves in a syringe. So this is the volume of the liquid, the gas inside this syringe. This is a gas inside a syringe. Now, what will happen when you apply more pressure here? When you apply more pressure here, what will happen? So let's assume this is the initial pressure. This is the initial pressure, pressure 1, and this is the initial volume, volume 1. Now, if you come and apply high pressure, a higher pressure, what definitely will happen is that this plunger will go in this direction, طبعا, and the volume will decrease. The volume will decrease. The volume of this thing will decrease. So your gas now will have a smaller volume, but P2 will be higher. This is a high pressure. So this is your gas. This is the new volume of the gas. So my question is, why is it that this is the same plunger, okay? If your finger was here, طبعا you will feel the higher pressure. If your finger was the one here, if you hold the opening of the syringe, you will feel the high pressure. So you can clearly see that if you reduce the volume is V1 and V2, the pressure increases. Or you can say it in a reverse way. This is the pressure. If you increase the pressure, the volume reduces. If the volume reduces, they are always opposite each other. How would you explain this? How would you explain this? So a question can be phrased like this: explain why the pressure, they don't start the explanation with the volume. They say the pressure increases when the volume of a gas is decreased. So explain why the pressure increases when the volume of a gas is decreased. So again, it's the idea of collisions. So we are saying the reason why this gas is exerting pressure is because of the idea of collisions. But look at these particles and look at these molecules of this gas and look at these other molecules. So what's happening? Which one is colliding more frequently? So we are saying it's because in a small volume, طبعا I'm assuming that the temperature is not changing, it's at the same temperature. In a small volume, you have more frequent collisions. So you have more frequent collision, and this is what we mean. In a small volume, you have a more frequent collision. So let's assume these are two containers like this, and this is a molecule that is vibrating up and down. So in a small container, if the container is small, the vibration is like really fast, more frequent here. But see, here it might be moving at the same speed. But since the container is big, the vibration is not as much. So you will have more frequent collisions. طيب يا شباب, never ever say faster. The molecules will not move faster. Don't use the word faster to explain such a scenario. You only use faster if there's an increase in temperature. But if a question tells you that the temperature is constant, you cannot say the molecules vibrate faster. So you say there is just more frequent collisions. Assume you are bouncing a ball in a very big room and in a very small room. So the ball will just hit more frequently the small room. Okay, so it's the same thing that happens. So you have more frequent collisions, and then now you can continue the explanation. You'll say you have a greater force. You have a greater force, and you know why there's a greater force? Because there's a greater change of momentum, and then there's a greater force, and then you'll have a greater pressure. So know when to use the idea of more frequent only, and when to use they collide faster. The idea of using they collide faster. When will you say the collision is more frequent and the collision is faster? So when there's an increase in temperature and the pressure is increasing because of a temperature increase, you say it is because the speed of the molecules has increased. But if it is only, there's no change in the temperature and it's only because the volume is small, then you say it is more frequent collisions. So be careful about that. Not only that, ya shabab, you are told that the pressure and the volume are such a way that if you always multiply, like P1 multiplied by V1, it's always equal to P2 multiplied by V2. How's that? Like if here the pressure is very small. Look at this. the pressure here is very small, but the volume here is big. Here the pressure is very big, but the volume is small, in such a way that when you always multiply the small and the big and the small and the big, you always get the same value. And we always come with a relationship and we say P1 V1, the pressure of any gas, P1 V1 is always equal to the P2 V2, as long as it is the same gas at the same temperature. As long as the temperature is the same, P1 times V1 will always be equal to P2 times V2. Like if the pressure here was let's say 40 pascals, and the volume here was, let's say 10 pascals, 10 centimeters cubed. So multiply 40 and 10, you get 400. Now you increase the pressure from 40 to 80 pascals. Okay, so you will realize if you double the pressure, this one will reduce by half. يعني this will be 5 centimeters cubed. Such that if you multiply 80 times 5, you will still get 400. Thus, this rule is obeyed by any gas that is now in a closed container. In a closed container at a constant temperature. So keep this as your first formula. We'll work with it and you will understand it better as we go. The pressure multiplied by volume of any gas at any time is always a constant. This is another way to say it. Another way of saying P1 V1 is just by is equal to P2 V2 is just by saying that P multiplied by V is always a constant. P multiplied by V is always a constant. So that's all about gas pressure. Let's talk about the degree Celsius and the Kelvin scale. طبعا before this is new in the syllabus from 2023. Before this, they had the idea of testing you in thermometers and how thermometers work and how temperature is measured using a thermometer, but all this was out of the syllabus. So if you see any past paper question talking about a thermometer, sensitivity, how to increase, I don't know what, a thermocouple thermometer, all those things are out of syllabus, and ignore those questions. But what is still in your syllabus is the units used to measure temperature. So all these are units used to measure temperature. They're obvious. The first thing you have to understand, degrees Celsius and Kelvin. How do you convert from degrees Celsius to Kelvin? So we are saying if you have degrees Celsius and you want to convert it to Kelvin, the Kelvin scale, you just add 273. Okay, if you want to convert from here to here, and if you want to convert back from Kelvin to degrees Celsius, you just subtract negative 273. As simple as that. So room temperature is around 25 degrees Celsius. Or if I want to change it to Kelvin, I want to change degrees Celsius to Kelvin, I'm going to say 273 plus 25. This becomes 298. So this is the same as 298 Kelvin. These two temperature scales are the same. Where did the Kelvin come from? So we are saying the Kelvin is simple. Look at this. Assume I have a graph of volume and temperature in degrees Celsius, temperature in degrees Celsius, and let's say volume in whatever units you have, centimeters cubed. What do you think happens to this? Is the zero, and this is negative because temperature can be negative, it can be below zero. What happens when you heat a gas? It expands. Why does it expand? Very simple. We are saying if you heat any gas in a container, it expands. The molecules move further and further apart, and it gets bigger and bigger and bigger. They move further and further apart. Why? Because they are moving what? First, they are gaining kinetic energy. They move further apart. The distance increases. So when you heat a gas, as the temperature increases, the volume also increases. They go up like this. So as the temperature of a gas increases, the volume of the gas also increases. The gas expands more and more. The reverse is also true. When you cool it, what do you expect to happen? When you cool it, you expect this, like the temperature show, like as you increase temperature, the volume also goes up. Now we are saying if you draw this for any graph and you cool, what happens to the volume? The volume reduces. if you extend your graph, you will reach a point for any gas. You will reach a point where the graph cuts your temperature axis. This point here, if you think about it, if you cool, it contracts. If you heat, it expands. It gets bigger and bigger. The volume increases. Now, do you think if I cool it, the volume can decrease until it is zero? Never. It is just from the graph. Like if I extend this, it's just from the graph. But if you extend this line, let me just slightly do it like this. If you extend this line in a graph, let's say you plotted and then you decided to extend it, you will always realize it will always cut this at negative 273 degrees Celsius. It will always cut the graph at negative 273 degrees Celsius. That's why this number 273 is unique. For any volume of a gas, if you extend this line, you will always see it will cut it at negative 273. We obviously know that you cannot, this is not practically possible. Okay, this might be possible up to somewhere, but at this point it's not possible because the volume of a gas will never be zero. You cannot cool something until it disappears. The volume of a gas will never be zero. So we are saying at this temperature, this is where it is cutting the what? The x-axis. This way it is cutting the x-axis, the temperature scale. So that's why the 273 number is unique. And you can know that negative 273 degrees Celsius is the same as what? 0 Kelvin. Because how do you convert from degrees Celsius to Kelvin? You just add, I wanna convert this to degrees Celsius. I have a Kelvin, this is degrees Celsius. I want to convert it to Kelvin. What am I supposed to do? I add 273. So plus 273 and you get 0 Kelvin. Is where the scale actually starts. So this 0 Kelvin here is called the absolute zero. Absolute zero. What do we say? So what's unique about it? So we say this is the temperature. Is the temperature at which the kinetic energy of a gas is zero. Like there are no particles that are vibrating. Or you can say this is the temperature at which a gas has the least kinetic energy. When the gas has the least kinetic energy, we say that's the absolute zero. And that's why the number is important. The number is from a graph. And for any gas you draw, you will always see it will always cut it at negative 270 degrees Celsius or the 0 Kelvin. And the 0 Kelvin is what we call the absolute zero. Sometimes there are some books that will say it is the temperature at which the volume of a gas is assumed to be zero. Is assumed because we know it will never be zero. But on a graph, it looks like it is zero. But that explanation is kind of broken. So what we say is this is the temperature at which the kinetic energy of a gas is zero. Like the kinetic energy increases as temperature increases. But it reaches a point where the kinetic energy drops because you are cooling until the gases are not a single molecule is moving. That temperature is at negative 273 degrees Celsius. And we say it is the temperature at which the gas has the least what? Kinetic energy. That's all about the degrees Celsius and the what? Kelvin scale and the absolute zero. So I think that's all for this video too. In the last video, to conclude part 1 now, I will solve inshallah the TCQs and this worksheet here. I will solve a worksheet here about this kinetic theory and whatever we've studied, which has a multiple choice on paper 4. And I'm also gonna solve inshallah the teacher control questions. We'll just try to solve some questions here together, which are all of them are IGCSE questions. هذا والسلام عليكم ورحمة الله وبركاته.